So this is 3D trigonometry. I don't think it's the last time we'll be touching this, but for this lesson we're going to break 3D trig down into 2D, and essentially that is the main thing we have to do. Okay, so I've got an example that will explain this, and yeah, let's go for it. Okay, so what we have to do in this question is find the unknown angle, in this case theta. I tried to highlight it with yellow, but that wasn't the best idea considering the colours there. So we've got to find theta. But before we can find theta, we actually need to know this baseline here. So what I'm going to do is I'm going to do it in two steps. So I have to do my first triangle, okay? And so I'm going to do a triangle here, okay? Now this triangle is the GHE triangle, and it's a right angle triangle. It should be a right angle there. The question doesn't say it, but that's what it is. Okay, and that's what it's implying. And so if I were to highlight that, I'll show you which triangle I'm talking about. I'm talking about here, here, here. So this one that I keep highlighting it. So this is the main part of the lesson, is that you need to break things down into 2D. Now the length of GH, it is 12 centimetres, and that one is here, it tells us, okay? And I also can find out the length of EH, and I know that it is 5 centimetres, and that's from here, okay? Because that length is going to be the same as that length, okay? So I'm going to take all that information out, and now I can use some skills. My skills to find GE would be to use Pythagoras, okay? So let's go G, not with a highlighter. I'm going to use my blue pen. GE squared is equal to 5 squared plus 12 squared. This is using Pythagoras. So GE will equal the square root of 5 squared plus 12 squared. So GE will equal square root of 169, which is GE equals 13. So we know that this is 13 centimetres. So I can put that in this graph if you want. Okay. Now that hasn't solved my question, but I'm in a position now to solve. So I need to draw a second triangle. So, and really important that we label these triangles. So I'm going to put theta there, and I know that this is 13 and the height is 13. Now let me label them. I've got G, and this is E, and this is B. So I'm going to highlight the triangle that I've just done. So I'm doing this one, and this one. Okay, and can you see that the lengths marry up? Okay, so in your working out, what I really want to see is these triangles there, okay? And really important that we put the labels in, because they're not just random triangles, they're actually part of this bigger 3D shape, okay? So I just wanted to pause my working out just to explain what my expectation of what I need you to do. I'm going to put a boundary there for that. Okay, so now we're in a position that we can find the answer. If I label the sides, the angles here, opposite the hypotenuse, the right angle is always the hypotenuse. Opposite the angle is the opposite side, and then the other one must be adjacent, which is next to the angle. So which two sides have information on them? Well, it's 13, which is the adjacent, and also 13, which is the opposite. So that means I'm going to use my tan ratio. So tan theta equals opposite over adjacent. So tan theta, the opposite is 13, the adjacent is 13. So therefore theta equals inverse tan. 13 over 13 is just 1, so theta equals 45 degrees. Okay, so this angle here is 45 degrees. So we've done two 2D triangles to solve our answer of our 3D problem. So the main thing is in our learning goal, break down 3D into 2D, and we can do it with either Pythagoras or trigonometry. All right, peace out.